Hi everyone, it's Maggie, and in this video we're going to be talking about shielding and electron configurations. So beryllium in its ground state is 1s2, 2s2, and in one of its excited states is 1s2, 2s1, 3p1. And it's asking if the shielding for the remaining 2s electron change. Okay, so I'm going to start by sketching a picture of the d functions of the atomic orbitals involved. Okay, so we first have the 1s, which will look something like this. Next, we have the 2s, which will look something like this. And finally, we have the 3p, which will be much farther away. Look something like this. Okay, so it's asking us whether the shielding for the 2s electron changes. So it's asking us to compare whether the 2s electron, how it feels when it's being shielded by another 2s electron or when it's being shielded by a 3p electron. So when it's being shielded by another 2s electron, they're in the same orbital, so it's being shielded about 50% of the time, so about half the time. And when it's being shielded by a 3p electron, you can see from our d function, the 3p is much farther away, so it almost never shields the 2s electron. So if we're changing from being shielded about half the time to being shielded almost never, the answer to this question is yes, the shielding does change. The shielding is going to decrease. Okay, let's look at the next part. So the next part starts the same way. Beryllium in its ground state is 1s2, 2s2, and in one of its excited states, it's 1s2, 2s1, 3p1. And it's asking us to compare the shielding, the change in the shielding of the 1s electron versus the change of shielding in the 2s electron. So I'm going to start by thinking about the 2s electron because that's what we were just thinking about. So for that electron, if you'll remember, the shielding on that one is going to decrease from being shielded about 50% of the time to almost never. So it decreases from 50% shielding to almost never. Okay, so now let's think about for the 1s electron. So for the 1s electron, if it's being shielded by a 2s electron, it actually is being shielded a little bit because of this bump on the left. And that's probably being shielded about 10% of the time. Okay, so but if we compare the 1s to the 3p is very far away from the 1s. It's much farther out, so it's almost never going to shield the 1s. For the 1s, it's going to decrease from about 10% shielding to almost never. So if we compare these two changes, we can see that there's a greater decrease for the 2s electron. Okay, so part C says carbon has the ground state of 1s2, 2s2, 2p2, while carbon plus has the ground state of 1s2, 2s2, 2p1. And we're asked if the shielding on the 2s electron is greater in the neutral or the cationic carbon. So from the standpoint of the 2s electron, what's changing is in the neutral one, we're being shielded by 2p electrons, and in carbon plus, we're being shielded by only 2p electrons. Now, even though the 2p electrons hardly ever shield the 2s electrons, it's still there. So the answer to this question is that the shielding is greater for the neutral carbon. Okay, then we have our last part. So our last part says beryllium in its first excited state has 1s2, 2s1, 2p1 electron configuration. Rank the shielding for the electrons in the 3 different occupied atomic orbitals. So since I sketched it for part A already, a similar graph, I'm just going to go ahead and paste that in. So we can see the 1s, the 2s, and the 2p. So the most obvious one is that the 1s1 is being shielded the least. And we can see this because it's closest to the nucleus, and it's pretty much only being shielded by this little bump of the 2s. But other than that, it's not being shielded. So the 1s is being shielded the least. Okay, and now we have to compare the 2s and the 2p. So because of this bump over here, the 2s is a lot of the times in front of the 2p. So that means that the 2s is sometimes shielding 2p. So that means 2p is being shielded the most, and 2s is being shielded the next most. So in order, 2p is the most, then 2s, and then 1s.